Hi, my name is Ganre. I'm a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be looking at functions, more specifically the inverse of a function. And the syllabus point we're focusing on is find the inverse of a one-to-one function in simple cases. So the inverse, also known as the anti-function, reverses the operations of the original function. And for a function to have an inverse function, it must be a one-to-one function. And to check if a function is a one-to-one function, you use the horizontal line test. So below we have some examples that we will look at that will help us understand how we find the inverse of a function. When the original function and the inverse function are sketched together on a graph, they are reflected in the line y equals x. So this is our original function here. This is f of x, and this is our inverse function. It should be f to the power negative 1x. So when they are sketched together on a graph, they are reflections of each other in the line y equals x. Now let's walk through some examples to understand how we find the inverse. So number one, the function f is defined by f of x is equal to 2x over 3x minus 1 for x is greater than 1/3. Find an expression for f inverse of x. So we have our original function being f of x is equal to 2x over 3x minus 1. So we're going to start by substituting f of x with y. So it becomes y is equal to 2x over 3x minus 1. Then our goal from here is to make x the subject of the formula. So in this case, we're going to multiply both sides by 3x minus 1 to get rid of the denominator. So it becomes y times 3x minus 1 equals 2x. And then we expand the bracket, we get 3xy minus y equals 2x. And then put the terms containing x on the left hand side. And then now we are going to factor out the x. So it becomes x times 3y minus 2 equals y. And then make x the subject of the formula by dividing both sides by 3y minus 2. So it becomes x is equal to y over 3y minus 2. So now this is effectively our inverse function, but however we want to write our function in terms of x. So you're going to replace this x now with f inverse of x, and then wherever there's a y, you're going to replace with x. And so your final answer will be f inverse of x is equal to x over 3x minus 2. That's the inverse function. Now let's look at another example. The function f is defined by f of x is equal to x squared minus 4x plus 7 for x is less than 1. Find an expression for f inverse of x and state the domain of f inverse. So we have our function here, f of x is equal to x squared minus 4x plus 7. Again, substitute f of x with y. And then for a quadratic equation, to find its inverse, we first have to complete the square. So in this case, we complete our square and we get y equals x minus 2 squared plus 3. And again, the goal is to make x the subject of the formula. So here we'll start by moving the 3 to the left hand side, and it becomes y minus 3 is equal to x minus 2 squared. Now we take the square root of both sides to get rid of the power 2, and it becomes plus or minus root y minus 3 equals x minus 2. Then move the negative 2 to the left hand side so that x is the subject of the formula, and you get x is equal to 2 plus or minus root y minus 3. Then here you notice that we have two signs, but we don't want to take both of the signs. So to determine which sign is correct, we're going to come back and look at the domain of our original function. And because our original function here is less than, it has a less than sign, it means we take the negative sign. if our domain was, for example, x is greater than 1, it means we would have taken the positive sign. So less than sign means you take the negative sign, greater than you take the positive. So in this case, to choose between these two sides, our domain is x is less than 1, so it means we are going to take the negative sign. That's why here it says x equals 2 minus root y minus 3. And then again replace x with f inverse of x, and then wherever there's a y, put an x. And the question also requires us to find the domain of our inverse function. So there is a relationship between the range of the original function and the domain of the inverse function. So the range of f of x is domain of f inverse of x, and then domain of f of x is range of f inverse of x. So the range of the original function is the domain of the inverse function. The domain of the original function is the range of the inverse function. So in this case, the question requires us to find the domain of the inverse function. So that is the same as the range of the original function. So our original function is f of x is equal to x squared minus 4x plus 7 for x is less than 1. Okay, so if we were to sketch our curve, we know that it has a turning point at the point 2, 3. So we know that this is the turning point. So if we were to sketch it, it looks something like this. Then our domain is x is less than 1, so 1 is here. So it means that what we want is this region starting from 1 going this way. This is our function. And then if we can find the y value here when x is 1, that will give us our range. So if we substitute into our equation here, it becomes f of 1 is equal to 1 squared minus 4 times 1 plus 7, and f of 1 is equal to 1 minus 4 is negative 3, 7 minus 3 is 4. So we know that this point here is y equals 4, and as you can tell, our graph is increasing going up, so the range is y is greater than 4. And we said that the range of f of x is the same as the domain of f inverse. But remember that domain is always written in terms of x. So in this case, our domain for the inverse function would be x is greater than 4. And so if we scroll down, we know that our domain here is x is greater than 4. So our final answer is f inverse of x is equal to 2 minus root x minus 3 for x is greater than 4. Now let's move on to question number 3. Functions f and g are defined by f of x is equal to 4x minus 2 for x is an element of all real values, and g of x is equal to 4 over x plus 1 for x is an element of all real values and x is not equal to negative 1. Find the values of x for which f inverse of x is equal to g inverse of x. So let's start by finding f inverse of x. We know that f of x is equal to 4x minus 2. So we start by replacing f of x with y. So it becomes y equals 4x minus 2. Then we want to make x the subject of the formula. So we're going to move the negative 2 to the left hand side. So it becomes 4x is equal to y plus 2. And then divide both sides by 4 to make x subject of the formula. So f inverse of x is equal to x plus 2 over 4. Now we also need to find g inverse of x. So g of x is equal to 4 over x plus 1. Substitute g of x with y, so it becomes y equals 4 over x plus 1. And then our goal is to make x the subject of the formula. So in this case, we'll multiply both sides by x plus 1 to get rid of the denominator, and it becomes y times x plus 1 equals 4. Multiply out to expand the bracket, and you get xy plus y equals 4. And let's make x the subject of the formula by moving this y to the right hand side and then dividing both sides by y. And we get x is equal to 4 over y minus 1. So that means g inverse of x is equal to 4x minus 1. Now we can equate f inverse of x to g inverse of x, and it becomes x plus 2 over 4 is equal to 4 over x minus 1. And from here you can simply solve for x. You end up with a quadratic, and you solve. We've got our quadratic here. You solve your quadratic and you get your 2x values and therefore your final answer. So that's it for this video. Thank you for watching. If you want access to this PDF, I've left a link down below in the description. You can also access more of my resources on my website. The link is also in the description. Thank you for watching.